The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody. Welcome to another another AMS webinar. Today's topic is power tips for MecSoft CAM. My name is Joe Anand, and I'm the product manager here at MecSoft. I'll be joined by Don LaCourse, our senior support manager here at MecSoft, and he will be doing the demo and also talking about some of these the topics of today's webinar. Before we get started, as usual, some of the Don, you want to go to the next slide? You can use your chat window for questions, questions and answers during the webinar, and hopefully, if we have time at the end, we'll reserve some time. But typically, our webinars have been running over time, and so we like to keep it as interactive as possible. So go ahead and input your questions in the chat window, and we'll be monitoring. Two of us will be monitoring in the background, and we'll answer them as we go. And then, of course, the recording of the webinar will be made available and sent to all the registrants for the webinar in a couple of days. So, all right, today's, as I mentioned, the topic of today's webinar is power tips for MecSoft CAM, tips that can help you be more productive with our CAM products. And we're going to start the topics with dialing in accuracy. It's a very popular or a very sought after topic that we deal with in support. How do you actually dial in the accuracy of your toolpaths? And then we also will talk about optimizing system performance. Then we'll talk about toolpath properties, some of the things that people don't know about this toolpath properties. So it's kind of like a hidden feature that we want to highlight here. And then also using G-code backplotters, which is a very useful tool that we find that many of our customers don't use, but we would strongly urge you to take a look at that. And then the last two topics would be post-processing tips. Again, there's a whole host of things that we can talk about in post-processing, but now we're just going to be talking about some tips to make you more productive using our post-processors. And then finally, navigating licensing, which is, again, a big area of support. So we want to talk about that and explain what we have in terms of the licensing models. So Don, without any further delay, go ahead.
Okay, hello everyone. Glad you could join us this morning. I hope everyone is feeling well. We're going to be talking about a number of important topics in this webinar. And the first one that we're going to be talking about is accuracy. Now, accuracy, as you know, is a relative term. In other words, accuracy may mean one thing if you're cutting wood or signs, okay? Or it could be mean something totally different if you're cutting metal, as in molds or anything that requires high precision. So our CAM products are designed so that you can, I call it dialed in, but you can adjust various accuracy settings in order to get the output or surface finish, because accuracy always, typically relates to surface finish that you need in the product. So I've got all the different dialogues up on the screen. We're going to start from the left, top left over here, and we're going to work our way down to the right. So the first thing you will notice is that there is a toolpath icon in the machining job folder right here. So every machining job has a folder. Every folder has a number of icons. And if you look at the icon for toolpath, if you double click on it, it will display what we're calling the toolpath viewer / editor. Depending on your configuration, you may only be able to view the toolpaths. Higher configurations, you can actually edit the toolpaths from this dialog as well. But if you look at this arrow here, you see the decimal places for every coordinate is 6 decimal places. That's just for display. Internally, our accuracy is up to, I believe, 14 decimal places internally in the product. So every coordinate that is calculated up to 14 decimal places. So if you need accuracy, there's nothing wrong with using that full width of decimal places to get the accuracy that you need. So open up the toolpath, open up the operation folders, double click on the toolpath icon. You'll see the toolpath browser. You'll see all of your coordinates and the precision of those coordinates.
Right.
Now,
We only display, hey, Don, I just want to break in here. We only
yep.
display 6 decimal points of accuracy, but like Don was saying, internally, we carry up to 14 decimal points.
Mm-hmm.
So just for display purposes, it's only 6. So.
Yeah. Okay, if we move over to the middle column, these are the dialogues that deal with tolerance. Now, accuracy is all about tolerance, okay? The tighter tolerance, the more accurate your finish is going to be. But then again, the tighter the tolerance, it affects your performance of your system, which we're going to cover in a moment. So as I mentioned, accuracy is relative. If you need the accuracy, the tools are there to get you that accuracy, but just be aware that higher accuracy does affect performance. So if you start at the top in the middle column here, in 2-axis, you'll see on the a global parameters parameter, and it has a tolerance. And if you look on that little picture on the right, you see the light blue faceted line. Toolpaths by definition are linear, so your CNC machine interprets points and going from point to point to point. So initially, those points are connected by straight lines. If you want to have a curve or an arc for a smooth transition, as a real arc, then you can fit your arcs to those points in the toolpath. And the tolerance that you see here is what is used to calculate the number of facets as it goes around a fillet or any curvature of your part. So the tighter the tolerance, the more facets that will fit in that curve. Then if you look at the next one down below, arc fitting, when you fit arcs to the points, okay, you're going to get a more accurate tool pass because it converts any 3 linear points to an actual curve. So those are the GO2 and GO3 motions in your G code versus the linear motions, the GO1s. So you can get higher tolerance without fitting arcs. Be aware that you're going to have a lot more segments. You can fit arcs to those linear segments and get an even smoother surface finish. Just be aware the tolerance. This is the arc fitting tolerance. Typically, we have it set to 2 times the global tolerance. So this is 1,000s up here. This is 2,000s down here. If you don't want to double that, if you can't have this large of a tolerance, then just swap these out. Do 1,000s for your arc fitting and half of that for your global tolerance. So be half a thousandths up here and 1,000 down here, or whatever you need to do. Then also 3 and 4 axis, this dialog right here. In 3 and 4 axis, we have 2 tolerance values, a high and a low, or what we call an in tolerance and an out tolerance. If you look at this picture here, we're talking about, if you see the part finish and the stock finish, the in and the out will determine how those linear segments are calculated across your part. So these 2 tolerances here will determine how much is out and how much is in. So again, the tighter these tolerances, the better surface finish, but the more segments you're going to have. Even if you fit arcs, depending on the contour of your surface, you may have a lot of arcs, okay? Or you may have just 1 arc or 2 arcs, depending on how close your curvature is to a true arc. And down here, that's not used a whole lot. I'm not sure how many 5-axis users we got listening, but in 5-axis, you can also obviously control your in and your out tolerance. It shows you the dialog down here. Now, again, to reiterate, tolerance is relative. If you're not worried about your tolerance, you're cutting signs or you're cutting wood, and you're not, it's, you're not doing any really fine inlay work or anything, you may not even have to mess with any of these. Just the default values will work fine. If you need the tolerance, you can go in and you can adjust these parameters. But as a counterpart to this, you want to make sure that you're out. If you look on the right dialog here, this is the post processor generator. So for your post, you want to make sure that you're outputting the number of decimal places required with the accuracy that you're trying to meet. So if you want to output 6 decimal places, okay, to get accuracy all the way up to that 6th decimal place, you want to make sure you go over into your post and make sure that it's outputting the number of decimal places that you want to meet or want your controller to read. So this one is set to 5 right now. This is 5 decimal places. When you post the code, you'll see 5 decimal places to the right of the first decimal of the decimal place. So that's just accuracy in a nutshell. The thing to keep in mind here, again, I mentioned a couple of times, accuracy is relative. The higher the accuracy, the longer it's going to take to cut apart, or longer it's going to take to calculate a toolpath, the longer it will take to simulate a toolpath. So if you need the accuracy, use it. If you don't need it, no sense in bogging you down if you don't really need it. So let's go over to the next topic. Performance indicators. We have an entire webinar dedicated to performance. I boiled down just the highlights here in 2 slides. I will put a link to the performance webinar in the video description when we send this video out, so you can go back and look at that entire webinar on performance. So basically in performance, there's 3 types. There's your hardware performance, your computer, making sure it's up to snuff to, operate our CAM plugin, because any CAD, whether it's CAD or CAM, it requires a lot of computer resources. So you want to make sure that you have a computer that can meet the needs of the program. In the middle here, we see toolpath generation performance. We mentioned it just a moment in the previous slide. Higher accuracy, longer it takes to generate your toolpaths. Again, on the right, simulation performances, the same goes there. The tighter the tolerance, the longer it'll take to simulate. But we have shortcuts that I'll show you for simulation, so you don't have to sit and wait through, an hour of simulation if you don't really need to. So let's go talk in more details on 3 of these topics. I know we got a lot of info. I boiled all of the information down on 1 slide, so we'll go through it kind of slow. We'll start on the upper left. We have just the different sections. I'll just go over the sections. We got the system recommendations, or the system performance, on the top left. We have geometry recommendations, which type of geometry is more, you'll get better performance with, and which you won't. Tips, just operating tips for better performance. Then we have toolpath generation performance up here, and toolpath simulation performance on the bottom. So let's just start on the upper left. System performance. If you're going out to buy a new computer just to run our program, it's highly recommended you follow these parameters. These are higher than, if you look at our system, the base requirements for the program. If you find that in our online help, it won't be as high as this. But we recommend that you go higher than what we suggest for a baseline, because that's just, a minimum. If you run, easy parts, you're not real complicated, you may be able to get away with your base requirements, but I would not even go with the base requirements. If you're buying a new computer, might as well make it work for you. So again,
also, Don, the system requirements are also in our website. If you go to the facts section of our website, you can find that. Okay. I'm going to add that to the chat window. So if you ever want to get a new computer, that's a good reference point for you.
Okay. Um, just a couple of items on system. The faster your clock speed or gigahertz, you'll see that in your system, Windows system information, is the faster your post processor is going to work for you. And also with CPUs, you can obviously get multi-core CPUs now. Most computers are multi-core. I don't think you can get a single core anymore, actually. But for your multi-core, get the fastest processor and get as many cores as you can afford. Quad core, 8 cores, whatever you can afford. I would definitely go for it. Um, for the disk drive, I would stay away from the hard disk drive, the standard drives, where you got, a disk and the needle is moving on this spinning disk to get your data. You want to stay away from all that. Just
Or the
use,
mechanical,
yeah,
what Don's talking about is the mechanical discs, the old SATA type of discs.
yeah,
So we definitely recommend solid state.
yeah. Go with a solid state drive. There's no moving parts, and also go with as much RAM as you can. Um, the system that we run here typically have 32 gigs of RAM, um, which should be enough for almost anything that you need to do. And then obviously CAD is highly graphics intensive, so you want, if you can afford it, um, go with a graphics card versus an integrated graphics on your motherboard, which typically come with any baseline computer, integrated Intel graphics. If you can afford it, get a separate dedicated graphics card such as NVIDIA. That's what we use here, and get as much RAM on that card as you can afford. So the basics here: speed, performance on your drive, max out your RAM, get a dedicated graphics, and get as much RAM on that card as well. So let's talk about geometry recommendations. 2D is very fast. I'm talking about calculating toolpaths and simulating toolpaths. 2D toolpaths are very fast. 2D geometry is very fast. Typically, you would have a 3D model, which is pretty much normal performance. So you'll have surfaces on that model that the program will calculate, interpolate the points across the surface, and that's pretty much the way you work. Now you can also work with a mesh model, which is different than a 3D, call it NURBS model. The mesh is a polyfaceted model, which has a lot of mesh facets. Typically, you'll see meshes if you're getting data from a 3D scanner, or if you're getting models, downloading models from the internet. Pay attention to whether it's a mesh model or a NURBS model, because meshes connect. You get up. I mean, if you're scanning something, typically users, they up the top, the accuracy on the scanner as far high as it'll go, and then you'll end up with 5 million facets in this mesh that you have to cut, which is not good, because it'll take too long to actually calculate, and you can actually run your system into an infinite loop of calculation if you're doing meshes and the mesh is too dense. So, but we have a module for that. We have a mesh module if you want to get into mesh modeling and how to work with your meshes and get them more pliable to use with CAM. So tips for better performance. These are just basic tips. Make a habit of rebooting your computer every day. The longer that computer stays up, the more processes it's churning in the background, and you get a lot of things going. It can actually slow you down when you come in on the next morning and want to get to work. So just make the point to close all your programs. If you want to shut it down at night or shut it down and reboot in the morning, however you want to do it. Minimize the number of sessions that you're running. For instance, if you're running Rhino and RhinoCam, try to make a habit of only using one or opening one model at a time. A lot of times people will have models in the background of multiple sessions of Rhino, that you're not using at the moment, and you pop them up and use them when you need them. Just be aware that that's draining your system resources. So always work with one model at a time if you can manage that. Also, programs, both the Visual CAD CAM and RhinoCam have, or Rhino has autosave options that can save your butt if you have a problem. Let's say you're running a toolpath on a very dense mesh and it's just in an infinite loop. You can't wait any longer, so you got to kill the program. You want to make sure that you have your autosave so you can go back to a relatively recent version of the part. And then I'll show you here how to allocate priorities to your RhinoCam or your Rhino application. I'll show you how to do that. Toolpath generation. Again, the higher or the tighter the tolerance, the faster, the higher the tolerance, I should say. We talk accuracy, high meaning it's less accurate, low meaning it's more accurate. So the tighter the tolerance, the faster it's, the slower it's going to be, sorry, for the generation. So the more relaxed your tolerances are, the faster the generation and simulation will go. So just on Toolpath, the cut patterns, the offset and the linear cut patterns are the faster cut patterns. Any pattern that you can fit an arc to, which typically is your offset pattern, you can fit arcs to that on your XY plane or your three principal planes. Those will be the fastest. If you get into your spirals and your offset spirals, you cannot fit arcs to those. Those will be all linear, so it's going to take longer to use a spiral toolpath. Just for tools, end mills are fastest. If you're going to do roughing, always use an end mill to do your roughing and not a ball mill. There are some situations where you might want to use a ball mill. That typically has to do with fillets in different areas to make sure that you have a fillet there to work with on subsequent operations. But typically end mills for roughing, ball mills for finishing. If you really need to use a tapered mill, that's going to take slower to calculate and it'll take longer to simulate. But sometimes you may need a very, very tight ball for the accuracy that you need. And in order to get that ball on a tool, it's typically a tapered tool where the ball's only on the tip and it tapers up to a larger shank diameter. Those tools will be longer, take longer to calculate the tool path. Simulation.
Oh, Don, I just wanted to break in here again. One of the things you might know that Don's talking about toolpath generation, it applies mostly to 3-axis machining, 3 and higher, 3, 4, and 5-axis machining. I mean, it does apply to 2-axis also, but the speeds of computation in 2-axis is so fast that you wouldn't even notice it. Right. So that's the point that I want to emphasize here. So if you are doing a lot of 3-axis sculpted surface machining, then these points are important to keep in mind.
Good point.
Thanks.
So again, with toolpath simulation, again, a note about the tolerance, tighter tolerance, the longer it takes to simulate. We got preferences that'll help you simulate faster, and we'll talk about those. And these next 2 items, I'll show you how to do those on your machining job tree, and just some couple of notes about when to simulate and when you don't need to simulate, or when you have to simulate. Okay, so let's go to the next slide. We're going to talk about Toolpath Properties. Not many people or new users know about the properties that you can adjust for any given toolpath. If you look on the left here, just right-click on any operation in your machining job. You'll get a menu, and you'll have a number of things you can do. If you look at, it has a properties option. If you pick that, you'll see this dialog right here on the top in the middle. That is your machining operation properties. You can do a number of things in here that you may not be aware of. If you want to output comments anytime that operation is posted to your G-code, let's say you want some operator notes or whatever, on a particular operation, you can put those notes in here within brackets or parentheses, and it'll output that. I'll show you how to do that. And then you can also assign a color. This is important if you got a lot of different tool paths and you want to distinguish one simulation path to another. You can assign each operation to a specific color.
One other note, Don, on the comments to output, it doesn't necessarily mean you just have to output comments. We've actually added G-code output there as well.
Yeah.
I believe if you wrap it with a % sign, it'll be output as G-code, is not as a comment. So you can actually set up some specific G-code that you want output for a particular machining operation here if you want it.
And then also, it's got some just some properties information at the bottom. Previously, the output, your file name. That's good if you're running a lot of Toolpath and you're archiving your G code. This will tell you what file name was used and when it was last posted. So that's some good information for you. Now, regarding to the simulation color, you can set your color, but you have to go in on the simulation tab and set this menu here to mop. Otherwise, it'll just use the default colors that are defined in the CAM preferences. So in order to get these different colors when you simulate, as you can see over here, you have to set this to mop. And then over on the right, we see it's just a sample G code with some comments outputted. Now let's talk about G code back plotters. Why might you want to back plot your G code? Well, typically this will come into play if you're getting an error on your machine. Say it's stopping at a certain line and you get an error message, and the controller machine won't cut any further. So you need to resolve that error. So in order to get in and help you debug what that error means, you need to get into the G code and look at, typically any error message on your controller will have a line number. Where in this G code file was this error created? So you need to go back to the G code file, the line number, look at the line number, see what's going on that line number that might cause an error. So you need to get into the G code. So, if you, as I mentioned previously, where you could, double click on the toolpath icon and see your toolpath viewer, that just shows you the motion coordinates. Okay, that's not G code. Okay, you only get G code after you post process your operation. So that's what we're talking about here. The G code files that you send to your machine or carry over to your machine and plug it in with a thumb drive, the G code files is what you're looking at in a back plotter. We do have a module, backplot G code editor module that you can use to look at your G code and edit it if you like. There's some controls up here that you can work with it. Or you can use some third-party G code viewers / editors. We have ours listed at the top. If you're an AMS customer, you'll get the G code module along with your CAM modules. If you want to use third-party editors and viewers, we have some listed here. Free to medium range, high end down here. But basically, what these are doing is these are reading the G code coordinates and the codes that are in your G code file and graphically showing you what they mean on your computer before you send it to the plotter. So that's important to just, you can see your G code graphically, and a lot of times errors will blare out at you. You say, oh, that's not going to work. These arcs are all over the place or things like that. Or you can go through it line by line and look at where the tool is on that line and what it's doing. So they're very good for helping you debug and your G code. Okay, we got 2 slides here for post-processing tips. So a lot of time, not a lot of times, but a lot of users, they may run into a situation if you're new. You may run into cases where all of a sudden your post processor is no longer listed in your selected post dialog, or it's not listed up here under the machining job. You're not sure where it went, why it did that. we're going to tell you how to fix that and deal with it and how to make it so it won't disappear again on you. We're also going to look at some, there's a post-processor tab on the CAM preferences dialog. We'll show you that and talk about some of these when we do the demo. Also, output control. We talked about arc fitting, and you can use this to turn on or off your arc fitting. If your CNC machine doesn't support arcs, you can turn the arc fitting off and output linear motions. Or there's a number of things here too. You can also output spirals as linear motions. You can output your drill cycles as linear motions if your CNC machine does not support what's called canned cycles. Canned meaning that there's predefined drilling operations in your controller. So we can call those when we G-code a drilling operation, for example. We can tell it the code, and it's just one line of code that has all of the information needed to drill that hole. Well, your machine has a built-in can cycle that understands what the codes are for can cycles. If your machine doesn't, you can convert your drilling to linear motions where it's just straight point-to-point, simulating the same drilling operation, but just using G-code coordinate motions to do that. Over here, we also have some user interface parameters that can affect post-processing, and we'll go over those as well. Okay, Joe, you want to talk about licensing?
Let me jump in real quickly. So basically, I just wanted to discuss the licensing models we have currently in the 2023 product. This applies only to the 2023 product because some of the older licensing models are obsoleted and will go away. And so moving forward, we will be, giving users the access to only 2 of these license models. One is called the cloud license model, which is basically for single users or multi-seats, maybe 2 or 3 seats. If you have in your company, then we typically would provide that company with a cloud license model. The advantage is as opposed to a node lock, which we used to send out before, is that the license will automatically be released after 8 hours of non-use. So let's say you're using the license in your company, and then you come home, but you forgot to log out of Rhino or Visual CAD CAM. Then after 8 hours, then it automatically gets released back to the cloud. And so you can actually acquire that license from anywhere, any other computer that you have access to. And of course, you can activate it on any PC anywhere on the planet. So if you're traveling, you can access that license. So it's a very, very convenient license model. It can also automatically release it at any time, so you can manually release it at any time. Let's say you actually want to move to another machine at any time, you can manually release it, just like a node locked. And then this is a very common occurrence. Well, I wouldn't say common occurrence, but it does happen a lot because you have hardware crashes sometimes. Sometimes companies decommission machines without your knowledge, and your license gets locked out. Before, at the node lock license, we had to go through an entire process of removing the activation and then recreating a new license code, and it was pretty cumbersome. But now, as mentioned in the first point, after 8 hours, the license will be released, so you can actually acquire it from any other machine. The only caveat for this, for cloud license model, is you need to have an active internet connection during activation. So the first time you bring up the product, it will look for that. If the license is expired, it will look to acquire the license from the cloud. So at that point, you would need internet connection. So in the case of, there are some situations, some companies, some organizations like the military that are completely dark. We call them dark sites. They don't even talk to outside companies. They're not on the internet. They're completely dark. In those cases, we do still offer the license, the node lock license, but that's only for special cases. This is for most standard installations, we would offer the cloud license model. And then if your company had more than 5 seats or more, or some schools, we offer the network lock license model. And this is, we used to have a network license. Again, the administrative and the security issues regarding that was very high. We got a lot of complaints from that. So we kind of obsoleted that. And then we're going with the network lock license model, which basically has 3 components, and we supply all the 3 components, so you don't have to worry about it. So if you're not using network license model, it only applies to your company if you have more than 5 seats. And we'll help you set that up. And then the main reason for this, again, it uses a cloud license model. So again, the same advantages of all the cloud licensing you get through the network license model, but we've added one level of security on top of it to prevent theft and loss of licenses. So these are the 2 models that we'll be offering. We've already started offering that in 2023, and then moving forward, this is the plan for all future releases as well. So thanks, Don.
Okay. Let's go to the next. Okay, we're at our demo time. Let's go ahead and hop in. Okay, I got a part here, just a 3-axis or a 3D part. It's 3D geometry. If you have a 3D part, say you got your part from somebody, say you're just you're just a cut shop and you get drawings or parts from your customers, you can look at your geometry and it'll tell you what type of geometry it is. For example, if you just select the geometry itself, we'll go up here. This is in Rhino, by the way. Rhino, this is Rhino 7, right now. We do support 8. If you go up here, and it'll tell you it's a closed solid poly surface. Okay, so poly surface, if you see that, obviously you know it's a solid model. It's a nerve surface model, which is the most accurate model you can work with. I don't have a mesh model up, but if you had a mesh model and you looked at the information, it'll tell you it's a mesh. So you just want to be aware of that if you're not sure if you're getting a mesh or not. Because working with a mesh, it has another set of complications that you need to deal with. So let's talk about accuracy. We're just going to pick one of these operations. I have a number of operations here. This is just a pocketing operation. I'm going to open up or expand it and locate the toolpath icon, and I'm going to double click on it. And what pops up is the toolpath viewer / editor. If you are using Express or Standard, you'll only see one tab up here, I believe, just for viewing the toolpath motions. This is not G-code that you're looking at here. These are just coordinates. This is the actual 6 decimal places that you see in the background. It's actually 14, but you're looking at 6 decimal places for each motion. And as you work through that, you can see the tool moving, as you go to that particular motion. So this helps you before you post-process your G-code, just to take a look at your coordinates, to take a look at where the tool is at a specific line of code. So let's look at some of the tolerance parameters. Let's start with 2-axis. Let's go and edit this operation. So here we have a tolerance value up here. Currently this is set to 0.1. I'm not sure why it's that tight. Typically it's 0.001 by default. But if you look at this picture over here on the right, again, that explains how these linear paths are calculated across, say, a fillet, around a fillet or around a curve. Okay, so the tighter the tolerance, the more of these segments, the slower the simulation, the slower the calculation, the slower the machining time. But if you need tight, or you need a really good surface finish, you can adjust this accordingly. Okay, again, we mentioned that offset patterns and linear patterns are the fastest. Typically an offset pattern you will use most of the time. If you go at offset spiral or spiral, these are all linearized paths. You can't fit arcs to any of the spiral toolpaths. So if you have a tight tolerance on a spiral toolpath, there's going to be a lot of lines of code in your G code file. So just to be aware of that. And then we all, again, radial typically are linear paths. Well, you may get some segmentation if you have any cores that stand up on your model. Again, and high speed, typically you can run these up faster cut feed rates, which really is a whole separate class that we're not really talking about today. I won't really go in so much. Obviously, your step over is going to affect how fast your toolpath runs and how accurate your part is. So let's look at a 3-axis operation. Roughing, let's see, finishing. Okay, this is a 3-axis operation. Let's look at the cut patterns. You'll see that we have an in tolerance and an out tolerance, and you'll see what those mean. If you look at the little pop-up dialog here for out tolerance, it shows you, how much can the toolpath deviate outside of your part or your stock, and then in how much it can deviate inward. So between these two, the tolerances will control how close the tool actually is to the part that you're wanting to machine. Okay, so currently we don't have any arcs fitted, so you see all of the light blue motions. If you were to see dark blue motions like these dark blues, those are actual arc motions. Those are the GO2s and the GO3 motions in your G code file. Okay, and the light blue are your GO1 or your linear motions. Okay, so that's tolerances both 2-axis and 3-axis. 4-axis is similar and 5-axis is similar. I won't typically go into those. And again, the number of decimal places that you see here, I just want to reiterate this, the number of decimal places you see here, just because you see 6 places here doesn't mean you're automatically going to get 6 places in your G code file. You want to go up to your post and have your post selected and edit the post, and it will tell you here how many decimal places you're actually outputting. So we're only outputting 4 decimal places. So you'll only see 4 places. Let's go ahead and get out of that, cancel out of that. Let's just post that. And drag that over here. Sorry about that.
Hey Don, as you're doing that, do you think it might make sense to see the difference in the number of points being output when you change the tolerance? You think toolpath generation goes by pretty quickly to do that?
Oh, for two axis, as you mentioned before, it's going to be pretty fast no matter what you adjust.
No, I'm talking about 3-axis. Yeah.
Okay, I just want to mention here, this is the 4 decimal places. If you need to use all the way up, to 6 decimal places, change that in your post and you'll output the multiple decimal places. Now in the, as you were mentioning in the, let's see, we got, okay, well, let's look at this one here since it shouldn't be too long. So we see we have all linear motions. Okay, the light blue are all linear motions. And the number of segments in that motion is fully dependent on your tolerance. So if you go into here in your tolerance and you tighten up the tolerance, currently this is in millimeters, okay? Millimeters, we got 0.03 for intolerance. If you change that to 0.1, say, which is a tighter tolerance, and you can do the calculation, convert that to inches if you want. That's probably 1,000th, maybe, or a little bit more. 0.1, and you generate that. Let's generate that real quick, and then let's go ahead and post that.
You can look at the information. It'll tell you how many points.
Okay.
No, right mouse click and go information.
Oh, okay. No. So here it tells
Yes.
you 19,
190,
yeah,
192.
192,000, yeah. You know, with a tighter tolerance, you're going to get more go-to motions, and it's going to be, you know, it's going to take longer to calculate, longer to simulate, longer to machine, but you're going to get a better surface. Okay. If we go back in here and we change this back to say 0.1, just for comparison purposes. Okay, 0.1 compared to 0.01. Let's generate that. Okay, let's do the properties or information. Yeah, it dropped up 190,000 to 67,000. So that just demonstrates how your tolerance can affect your toolpath. It affects your speed, generation speed, simulation speed, machining speed, and your surface quality. Again, a higher tolerance will be less accurate. So you may see faceting in your actual machine surface that you're machining if you have a tolerance of 0.1 versus a tolerance of 0.01. You'll have a lot finer surface finish, but just going to take longer to calculate, longer to simulate, longer to machine. So just be aware of that. There's always this trade-off between accuracy and performance. So you need to understand for your job, how accurate do you need to be? And don't be any more accurate than you need to be, because it's going to slow you down every step of the way. Okay, so that's why it's important to pay attention to the accuracy, what's required for accuracy. Okay, let's move on along. We're getting a little bit short here. System performance. Okay, so let's go up here and let's go down into the task manager. I'm just going to type in system. Okay, let's go into the control panel and let's go system. Okay, just go system for now. And it'll tell you the information on your current computer, how fast is your processor, how much RAM you have installed. These are good things to know ahead of time before you buy the computer. Only run one session of your CAD program at a time. For instance, we're running RhinoCam. We only have one session of RhinoCam running. But if you'll notice, if you click on here and you go to the task manager, let's bring this over. I advise you to get familiar with your task manager because it'll show you what's running all the time on your computer. And if your computer's starting to slow down, you'll see it here what's causing as much a hit to your performance. But if you see that we got Rhino 7 running, if we go into details, and here's our Rhino 7, you'll see that you got all these operations that are running right now. Okay, so all of those operations are really jogging for resources on your computer, which may cause the Rhino that you want to run to actually slow down. So if you want the Rhino to have most of the resources, just right click on Rhino, go to set priority, and set this to real time. You can set different priorities for any operation. Okay, let's look at priorities again. Low priorities, normal, high, real time. I typically set it to real time. And that means that RhinoCam will now get all the resources before any other resources, unless the resource is a critical resource. Okay, so let's talk about Rhino options as far as your Rhino tolerance or your CAD system tolerance. If you go up to tools, go to options. And if
the
you
same applies to Visual CAD as well.
Yep.
So we have similar options.
Yeah. So again, if you go to Rhino, the main menu at the top, go to tools. Okay. And under tools, look for units. Typically it's not, you don't see the tolerance, but if you click on units, and it'll tell you your absolute tolerance. Right here, I have it set it to, I guess, 1, 2, 3, 4 decimal places or 5 decimal places. You can this will apply to any model that you if you import like a neutral or IS model that can help get a tighter model. if you adjust your tolerance ahead of time. If you're modeling any type of models, any type of 3D modeling in your CAD program, then this will help you get a more accurate model. So that's always important. So also, I talked about the geometry types, the 2D versus 3D models versus a mesh model. And then we mentioned also about the setting the priority to Rhino so that it runs ahead of other apps. And also, don't forget to reboot your computer daily. That will help with your resources. So Toolpath performance. Again, I keep reiterating tolerance affects speed, okay? So tolerance is relative and it relates to a direct relation to speed. I talked about the cut patterns. I showed you the different cut patterns. Part sampling resolution. If you look over here on your camp preferences and you go to machining, you'll see this part sampling resolution. If you have it all the way to the right, if you're working with NURBS surfaces, I typically have it all the way to the right, but that's going to calculate more sample points along that surface to generate those G-code segments, okay? So if you don't need, if you're not worried about accuracy, put this to the left and leave it there, and then it'll help your performance. Again, we talked about tool types. Flat mills are fast, ball mills are next to fast, tapered mills are the slowest. Also, I want to mention here in this option right here, always generate toolpaths in multiple threads. Any computer that you buy today is going to be a multi-core computer. And what that means, if I have it checked, then I'll just pick OK there. And let's go ahead and I'm going to actually delete that for now. And so when you regenerate all of them, I've got some invalid arguments. I just pulled up this part without actually examining a whole lot. But if you look at this dialog up here on the left, each one of these operations ran in a separate thread or a separate core. So if you have a long, if you were working on this part file for a month, I'm exaggerating, but if you were working on it for a month, your machining job, you may have 50 to 100 operations. If you want to regenerate all of those, using multiple threads will actually make that generation a lot faster because it will pop in each toolpath in one of these threads and calculate it independently from your other threads. So that really helps a lot. Let's get out of that for a second. Okay, let's see. Simulation performance. Again, tolerance affects
Hey, Don,
speed.
we're running out of time, so we want to speed it up a little bit.
Okay. Again, simulation, same goes for tolerance versus speed. We also have, when I reference you to this performance video, it'll talk about a lot of the things on the simulation, so I'll just skip those. And then, Joe, do you want to go ahead and cut out now and do you have any
No, what do we show? No, you need to show the post-processing.
Yeah. Okay, let's go back over to there. Hold on just a second. Post-processing. Okay. Here's something that can happen to you if your post, let's say you just upgraded to a new version. Typically, this may happen if you will from 21 to 22 or 22 to 23 or whatever. If you load a file and you see that your post is missing or it defaults to the first post up here, this post is the first post. So if you see that, then you'll know that it didn't find your post and it just popped up the first post that was in the list. What you can do in that case so that doesn't ever happen again is just open a new file, okay, and then go up and set to post, locate your post, set it to what it needs to be. I'm just going to pick one, okay, and pick OK. And then go up in your excuse me, in your CAM preferences. And if you look at user interface, what you can do is you can, let's uncheck this for a second. So you set your post the way you know the post that you want to use. Pick this button, save current preferences to your registry. That'll save those preferences to your registry so that when you open another file, that post will be called up again. Another thing you can do is to set not only your post, but whatever preferences you want to use in your file. Or you may have a sample toolpath or here that you can. You may have a number of samples that you have your defaults in. You can just go up here and pick and do a save as a template. Save as template. And what that does, that'll save out a template file. When you start a new Rhino session, it'll come up with that dialog. You may be aware of it if you run Rhino. You know, it asks you what template file you want to use. You can create your own template file with your post and everything set in it. Also, let's look at let's go back into the CAM preferences again. Let's look at post processor. If another thing that can happen, your program may lose which file extension your post G-code files should be in. By default, the posted file extension is .nc. We have a number of different file extensions, or you could create a new one and add it to this list, and you set that to the extension that you need to use. And again, whenever you save your premises to your registry, all this information is going to be saved to your Windows registry the next time you run the product. You got other preferences here relating to post-processing. You know, which application you want to use when you look at your G-code, but automatically. How you want to set your naming conventions. This option right here, if you see that you have a flag on your G-code icon and you're wondering what that is, and you're worried, well, okay, what does that mean? Is my G-code okay or is it not okay? All that means is that in your CAM preferences, post-processing, it means that this is unchecked. Always post-process G-code during toolpath generation. This is an option that we added to allow you to automatically generate your toolpaths whenever you automatically post-process your toolpath whenever you generate an operation. And if you have this on, click OK and you regenerate that, it should get rid of that flag. Other post-processing.
I want to discuss the location of custom posts. If you want to bring up the post dialog, yeah. So you see the folder for to load post processors file from. That's an important folder by default. What it normally points to the installation folder where we have a whole bunch of posts. So you don't need to show that down. Just show the drop down. Drop down on that current post processor. If you show the current drop down.
Okay, right here, you mean?
The drop, yeah. So if you see, there's a whole bunch of post processors here. Typically, most of our customers use one post. I mean, that seems to be the typical situation. So if you don't want to see all a list of this, what we would suggest is create a separate folder for your posts and then stick the post processor you're using into that folder. That way, if you get a newer version and you're installing the newer version, it's not going to override any changes you made to that post. You will always have that. And then even when you upgrade to the next version, you can still point to that. If in the install process you tell the installation program to actually import the settings from your previous version. So that's an important thing to keep in mind, because we do run into that all the time, because we do make some edits for people for post-processing and they stick it into the same folder, and then when they get a newer version, it overwrites it if the name of the post-processor is the same. So what we would suggest is to create a separate folder for any of your custom posts, or even if you don't want to change it and if you don't want to look at all these posts in the folder, that's what we would recommend you do that. So
Yeah, if you save your post to another folder, you can use this button right here to tell it where to go to find your post. Okay. Sometimes we just tell you to put it on your desktop since that's real easy to find. Or if you're on a network and you have a lot of seats and you may want to put your posts on a network drive, I guess that would work fine. But just put it in a place where you know where it's at, so it'll always point to that location. Okay. You want to continue, Joe? You got anything else you want to mention?
Yeah, the only thing I would also add is we do have the Python post processors. We talked about that in the previous webinars, but that's another good enhancement we introduced in 2023, and we are seeing a lot of uses for it. So if you need any specialized posts, we can handle those issues these days pretty easily. So let us know. That's all I have on the post.
Okay. Okay. So as I mentioned previously, we have dedicated webinars for post-processing, a dedicated webinar for performance. So I will link those in the description when you get the webinar video. Go to those links and you can watch the other videos. It tells you a lot more than what we discussed here in this video. Okay, we got any remaining questions in the background there? Okay. Okay. Looks like we're all set. We hope you guys
thank
have...
you. Yeah, no questions, Don. Sorry, I was on mute. So
that's okay. That's okay. If you guys get any questions, you can always send us an email to support@mecsoft.com, and we'll respond promptly. Again, I'll get the links to these other webinars in the description of this video. Take care, everyone. Have a wonderful day.
Thank you all. Thank you all. See you next month.
Bye-bye.
Bye-bye.